Hello, everybody. This is Mr. Desmond. I am here to teach you a little bit more about what you've learned with quadratic relationships. At this point, you have gotten pretty comfortable with the features of quadratics, and you've learned a little bit about how to find the zeros or the roots of a quadratic function, both from a graph as well as some of you may have learned how to do this with an equation. So this video will give you some more insight on why we're able to do that as mathematicians. So I'm going to jump into a quadratic here, this x squared minus 2x minus 3. We have this quadratic, and I want you to consider both the roots and its factors. Right, so we have this in standard form, and if we wanted to factor this, I'm hoping at this point from Module 9, you are all able to do that process. So we have x plus 1 and x minus 3. Now I'm hoping you realize that these are the factors of our equation. And looking at the graph, I'm hoping that you can identify that we have two different roots or zeros here. One of which is x equals -1, and that is where it crosses this x-axis right here. The other is x equals 3, and that is right here where it crosses the x-axis. So it crosses in two different places. So what we're doing is we're looking at patterns, and we are looking at what we can do with the information and the skills you've acquired. So we have x plus 1 here and x minus 3, and then we have our zeros or our roots as x equals -1 and x equals 3. Now, pause the video for a second and see if you can figure out what the relationship is between the factors and the zeros. Okay, so with those ideas that you have, I want you to consider just what is happening when we factor, right? It's two different pieces of multiplication. And I know a lot of you are probably thinking, all we have to do is switch the signs. And although that is something that is easy for students to confuse, I want to show you why that is not actually the relationship between factors and zeros. So what a bunch of smart mathematicians figured out is that multiplication by zero is an important feature that we can actually use when we want our output, or y, to be equal to zero. We can have two different numbers. So let's say I have the first number be 2 and the second number be 0. If we multiply those, I'm hoping you all understand that that is going to be 0. We could also have the first number be 0 and the second number be 4, right? And I'm hoping you realize if we multiply those, we will get a product of 0. The other feature is when both of them are zeros. These are the three main situations where we can end up with a 0 product, right? Either the first number is 0, the second number is 0, or both of them are zeros. And that is actually what's going to create our 0 product law, right? So what number plus 1 is going to give us this entire piece to be 0? -1. What number minus 3 is going to give us this entire piece as 0? 3. So it's not actually just flipping the signs, although it is very easy for us to think about that, right? So I want to show you the three different examples that are more than likely going to come up. We have the difference of perfect squares, trinomials, as well as greatest common factor. So if you would like, you can pause the video now to give these a shot. I am going to go ahead and jump right in. Let me move my head out of the way here, right? So difference of perfect squares, we have x squared minus 25. We can realize that first thing that we want to do is factor the left side of the equation, right? So x minus 5 and x plus 5, and all of that is equal to 0. Then we're going to strategically treat each one of those pieces as a product because we're multiplying. And what we're going to be able to do is on this side of the equation, we're going to find out what number makes that piece equal to 0. And we'll find that x is equal to -5. On the other piece, we'll be able to figure out what number is going to make this piece equal to 0, right? So I switched those around. That was my fault. But either way, we'll have two different solutions here. X is equal to -5 and X is equal to 5, because those are the values that make our equation true. Okay, so the difference of perfect squares example, that would be our final solution set right there, plus or minus 5. I'll move my head over here, and we'll jump into trinomials. So x squared plus 4x minus 12 equals 0. First thing we're going to do, we are going to figure out what factors of -12 will add up to 4. And that's going to be +6 and -2. Notice our factors are x plus 6, x minus 2, and that's all going to equal 0. We'll break this up into two different equations. On one side, we want what number makes this piece equal to 0? Well, that's -6. What number makes this piece or that product multiplication, right, equal to 0? And that's going to be 2. Leaving us with the solution set of -6 and 2. The last form of solving quadratics by factoring is going to come up with greatest common factor. So greatest common factor is another form of factoring. This one can be a little bit tricky for students because after the first step, many students are going to be able to factor this to get to 2x times x minus 7. They set everything equal to 0 because we're looking for where that quadratic crosses over the x-axis, where y equals 0, right? Most students won't struggle with the x minus 7. They'll figure out relatively quickly that x is equal to 7, right? So one of our zeros or roots is at 7. The one student struggle with is this piece right here, 2x, right? And all you have to do is actually figure out 2 times what number equals 0. Well, that's kind of why we started this process in the first place. So we reverse the order of operations, and we're going to find that x is equal to 0. Over here, we already went through, and we figure out our solution set. So overall, I'm hoping that this video was helpful for you finding more information about algebraic solutions to finding zeros of a quadratic. If you have any questions, do not be afraid to email or reach out. Thank you so much. Looking forward to seeing what you do next.